So everybody, we now have to talk about segment of a circle. So let's talk about segment now. Okay. As I had told you that sector is associated with arc, segment is associated with chord. What is segment of a circle? Don't confuse it with the sector. What is a segment? Region enclosed by a chord and the corresponding arc and the corresponding arc of the circle. You all know that the moment I bring a chord in picture, automatically its corresponding arc come into picture. Whenever I bring an arc in picture, its corresponding chord comes into picture, right? So I can just say that region enclosed by a chord. I don't have to bring in this arc in picture, it will already be there. So the region which is enclosed by the chord and its corresponding arc is known as the segment of a circle. Let's try to understand this. If this is a circle of radius r, it's a circle with center O, radius r, I just take any chord over here. See, this is the chord, any chord. So this is A, this is B, this is chord AB. Automatically, if I am reading this as chord AB, the arc corresponding to it is the AB arc, right? This chord is actually having AB arc as its corresponding arc. If I am reading it as the AB chord, then the region which is bounded by this chord and its corresponding arc is this region, and this is known as the segment. So a segment has boundary as a chord and an arc. A sector was having boundary as an arc and two radius. Depending upon the arc being minor or major, we said that sector was a minor sector or a major sector. Similarly, if I am reading this as AB chord, I know the arc corresponding to it is the AB arc, but I can read it as the BA chord as well, and in that case the arc corresponding to this chord would be the BA arc, and in that case I will be getting this segment of the circle. So even this is a segment. That means just like corresponding to one arc, I was getting two sectors. Similarly, corresponding to one chord, I am getting two segments. Obviously, you would have very nicely understood this is region having chord AB and arc AB. I should not write arc if I am drawing that curve, and AB arc as boundary. Fine. And what is this? This is the region having chord BA and BA arc as boundary. So obviously, this region is also enclosed by a chord and its corresponding arc. This region is also enclosed by a chord and its corresponding arc. Both are segments, but the region which is enclosed by a chord whose corresponding arc is a minor arc is said to be a minor segment. So this in this case is a minor segment, because minor arc is a part of its boundary. AB arc is a part of its boundary. I know that AB arc and the AB chord are its boundary. So AB arc is actually a part of its boundary, wherein the AB arc is the minor arc. So because this is the minor arc and minor arc is the part of the boundary of this segment, so this segment is a minor segment. Similarly, over here you can see BA arc is a part of the boundary of this segment, and BA arc is my major arc. And so BA arc, because it's the major arc which is a part of the boundary of this segment would be the major segment. Is it understood? So this is the minor segment, this is the major segment. The moment I have a chord, I actually get two segments, one minor and one major, because a chord is giving me a minor arc and a major arc. Corresponding to the chord and the minor arc, I get minor segment. Corresponding to chord and the major arc, I get major segment. Now please understand one thing very clearly. Our aim is to understand the area acquired by a segment, whether it is minor or it is major. Clear? Our aim is to find out the area of the minor segment, area of the major segment. But before that, understand one thing, that the area swiped by the minor segment, let's say this point is M, then region AMB. Region AMB is the minor segment, and region B, say this is Q, region BQA is the major segment. So you can very clearly see the region acquired by the minor segment plus region acquired by the major segment. Together, when you add them, you get the region acquired by the entire circle. What I am trying to say is that it's but obvious that area of minor segment plus area of major segment is equal to area of the complete circle. Is it clear? So now let's get ahead with computing the area of a segment. In here also we will only be interested in computing the area of the minor segment, because from the area of the circle, which is pi r square, if I remove the area of the minor segment, I will get the area of the major segment. So we are now interested in computing the area of a minor segment, okay? Let's see. So that's the circle. If that's the circle, say the center is O, radius is R, this is circle centered at O with radius R. Say that's the chord. This point is say A, this point is say B. I am interested in computing the area of this segment. Say this point is R. So I am interested in computing the area of ARB region, which is my minor segment. Minor segment. I wish to compute the area of this segment. So what basically happens, if you can see, this minor segment is corresponding to the AB chord and the AB arc, right? The AB arc is say subtending an angle of theta degrees at the center of the circle. So this is theta degrees. The AB arc, which is a part of boundary of the minor segment, because this is the minor arc, say it is subtending an angle of theta degrees at the center of the circle, then you can clearly say that area of ARB, that is the minor segment, area of this region is nothing but area of this sector, which is the minor sector of this circle of radius r having an angle theta, minus the area of this triangle OAB. When from the area of this complete sector OARB, I remove the area of the triangle OAB, I get the area of this shaded region ARB. So area of ARB is area of the sector, it's a sector, area of the sector OARB minus area of triangle OAB. What is the area of this sector OARB? In order to compute the area, what all do I need? I know how to compute the area of a sector having a certain angle sitting in the circle of a certain radius. So here OARB, or you can say OAB, is actually a sector. OARB, you can say OARB is actually a sector of this circle of radius r whose angle is theta. So what would be its area? It would be theta by 360 into pi r square minus area of OAB. What is area of OAB? This angle is theta degrees. So this angle is theta degrees. Area of a triangle is half into base into height. If I drop a perpendicular from O to the side AB and say this point is M, then OM is going to act as height of this triangle. So I will have half into base is AB, into height, which is OM. I need to compute the value of AB and OM in terms of theta and R, so that I can develop a generalized formula to compute the area of a minor segment. How to do that? Please try and focus upon these two triangles OAM and OBM. Focus upon these two triangles OAM and OBM. What can you see from here? If you focus upon these two triangles, you will clearly be able to see that OM is perpendicular to AB, which means that angle OMB is 90 degrees and angle OMA is 90 degrees. So one angle is same in both the triangles, which is a right angle. After that, OA is equal to the radius and OB is also equal to the radius. So one side is also equal, which is actually the hypotenuse, and you already have OM equals OM because it is the common side. So by right angle hypotenuse side, I have that both these triangles are actually congruent to each other. So angle OMA is equal to angle OMB, which is 90 degrees. Then you have OA is equal to OB because it is the radius, and OM is same as OM, it's common. So by right angle hypotenuse side congruence condition, I have triangle OMA is congruent to triangle OMB. And therefore by CPCT the corresponding parts will be equal. So I will have angle AOM is equal to angle BOM. BOM. Moreover, if you already remember the result that a line perpendicular from the center to the chord bisects the chord into two halves. So I have AM is equal to MB. Isn't it? A line perpendicular from the center to the chord bisects the chord. So I already by that result have AM equals MB, or it also comes from here AM equals MB as a part of CPCT. The moment I am having that angle AOM is same as angle BOM, I know if this complete angle is theta and AOM is same as BOM, I know that angle AOM plus angle BOM is theta. But angle AOM is same as angle BOM, so I can write this as AOM only. This is theta. So twice of angle AOM is theta, so angle AOM is theta by 2, but because angle AOM is same as angle BOM, I have angle AOM as theta by 2 and angle BOM as also theta by 2. Is it clear? Now that I have these angles measurement with me as theta by 2, focus upon the triangle AOM. Okay, if you focus upon this triangle AOM, this is a right angle triangle. What is sine theta by 2? Sine theta by 2. So in triangle AOM, I am wishing to compute sine theta by 2 and I am wishing to compute cos theta by 2. I can do that in a right angled triangle. Theta by 2 is an acute angle. So sine theta by 2 is perpendicular upon hypotenuse, so AM upon AO. AM upon AO. Fine. AM upon AO. AO is nothing but the radius. So this is AM upon the radius. So what is AM then? AM is R sine theta by 2. If AM is R sine theta by 2, what is AB? AB is AM plus MB. AB is AM plus MB. But AM is same as MB. Right? So I can write this as AM plus AM, which is twice of AM, but AM is R sine theta by 2. So AB is twice of R sine theta by 2. You have got AB as twice of R sine theta by 2. Let's talk about cos theta by 2. After sin theta by 2, let's talk about cos theta by 2. It is base upon hypotenuse, so it is OM upon OA. Again, OM upon the radius is cos theta by 2. So OM is R cos theta by 2. That means I have got the value of OM as R cos theta by 2. If AB is with me, OM is with me, I am just wishing to plug their values in here to get the area of the triangle. So I have theta by 360 pi r square minus half of AB. AB is 2r sine theta by 2, and this is r cos theta by 2. OM is r cos theta by 2. So clearly this 2 gets cancelled out. This r and this r is r square. Here also there is r square. So what you do is you take out r square common and you are left with pi theta by 360 minus sin theta by 2 cos theta by 2. Why? Because this is pi r square theta by 360 minus r square sin theta by 2 cos theta by 2. This is r and this is r. So r square. Is it clear? This happens to be the formula of area of ARB, which is actually my minor segment. So area of the minor segment you have corresponding to the angle of the minor segment. When I am saying angle of the minor segment, means that angle which is made by the minor arc or angle which is subtended by the minor arc sitting as a part of boundary of this minor segment at the center of the circle. AB arc was sitting as a part of boundary of this minor segment, which is ARB. So the angle which is subtended by this arc was theta. So I say theta is the angle of the minor segment. So pi into theta, that angle, upon 360 minus sine of theta by 2 cos theta by 2 multiplied by r square, where r is the radius of this entire circle, gives you the very area of the minor segment. Now please try to understand this very carefully. I am comparing two things now. Now I am talking about minor sector, major sector, minor segment, major segment together into one single setup. So please try to see this. This is circle with center O, radius r. I am saying this is A, this is B, this is my arc AB. So AB arc you can see is the minor arc. Corresponding to this arc, there will be a minor sector and a minor segment. Please try to see this. This is minor sector. Okay, so this complete, if I talk about this, is minor sector. And if I join A with B, this that you can see is the minor segment. One thing is sure, that area of minor sector is always greater than area of minor segment, isn't it? You can see this very clearly. Let me draw another diagram. Let me draw now another diagram of the same setup. So say that's the circle, center is O, so circle with center O, radius r. Again I have 2 points, this is A, this is B. If I talk about the BA arc, from B to A in the anti-clockwise sense, if I travel, then this is my major arc. Corresponding to this major arc, this is your major sector. So I can say this would be completely your major sector. And if I talk about if I talk about the major segment, I will have to join this, form the chord BA, below the chord BA and above the arc AB is the minor segment, and above the chord BA, below the BA arc is the major segment. So I actually have this is my major segment. Is it understood? And there is no doubt, you can very clearly see that the major segment has more area than the major sector. Area of major segment is greater than area of major sector. So area of minor sector is greater than area of minor segment, but area of major segment is greater than area of major sector. It's common sense, you can very clearly understand this. Now let us talk about an application of all of this. Let's discuss that now. So suppose I have the circle, center is O, and the radius is 10 centimeters of this circle. So this is a chord AB. Fine, and as I said, the radius is 10 centimeters. So this is the center. If the radius is 10 centimeters and the angle which this chord is subtending at the center of the circle is 90 degrees, find the area of the minor segment and the area of the major segment. If I say some point over here is R, then area of the minor segment, would be what? Let's get back to our result. Area of the minor segment is given by r square times pi by 360 into theta minus sine theta by 2 cos theta by 2. So you have r square, that is 10 square, theta by 360, so 90 by 360 into pi minus sine theta by 2, that is sine 90 by 2, that is 45, cos 90 by 2, that is 45. So you have 10 into 10 is 100. This cancels out. You have 1 by 4 into 22 by 7 minus 1 by root 2 into 1 by root 2, because sine 45 is 1 by root 2, cos 45 is 1 by root 2, which gives you 1 by 2. So you have 100. Here you get this. So you have 11 by 2 into 7 minus 1 by 2. Again 1 by 2 comes out. You have 11 by 7 minus 1. This gives you 50. 11 minus 7 is 4 by 7. 11 minus 7 is 4 whole upon 7. 200 upon 7 square units. Is it clear? So what is it that you have? Area of this minor segment is 200 by 7 square units. What would be the area of the major segment? Suppose I mark a point Q over here. Then what would be the area of BQA? Area of the major segment, which is this segment. This complete is your major segment. This would be area of the circle minus area of the minor segment. So it is pi r square minus 200 by 7 square units. Pi r square means 22 by 7 into 10 minus 200 by 7. So 1 by 7 comes out. You have 22 into 10, that is 2200 minus 200. So it is 2000 upon 7 square units. So from the area of the entire circle, when you remove the area of the minor segment, you get the area of the major segment. Is it clear? We did nothing, we just computed the area of this sector, which is theta by 360 pi r square, and then we said half into base into height. Half into base into height actually gave me the area of the triangle. From the area of the sector, I removed the area of the triangle and I got the area of the minor segment, and then from the area of the circle you remove the area of minor segment, you get the area of major segment. That completes our discussion over the area of segment. That's it from my side. Thank you.